Our lesson today is 3.2D. It is the final lesson for lesson 3.2. And in this lesson we're going to be learning to find the rate of change from a verbal description. Now in our previous lessons we've learned how to find the rate of change from a table, from a graph, and from two-order pairs. So I want to review those formulas real quick so that we're all on the same page and we all know how to find those rates of change in those different types of problems. The first formula we learned was from a graph, how to find the slope from a graph. We learned that m is equal to rise over run. In our second lesson, we learned how to find the slope from two-order pairs using m is equal to y2 minus y1 over x2 minus x1. And in our third lesson, we learned to find the rate of change from a table using m is equal to delta y over delta x, where the delta values stand for change in. So it's not a triangle, it's a Greek letter delta, so m is equal to delta y over delta x. In our fourth lesson today, we're going to learn to find the rate of change from what I call a verbal description. A verbal description is essentially just a word problem. So when it comes to finding rate of change from a verbal description or a word problem dealing with slope, we're going to use a formula that I actually came up with myself. The other formulas are pretty commonly recognized in mathematics, but this one I came up with myself. It's m is equal to delta dv over delta iv. And using that formula, we have to understand that the dv is going to stand for dependent variable, and the iv is going to stand for independent variable. Please write that down. So again, dv stands for dependent variable, iv stands for independent variable. So we're going to be looking for the change in the dependent variable over the change in the independent variable. And if I'm not mistaken, you guys have already talked about dependent variables and independent variables in science this year. We're going to be taking a closer look at those, and we're going to be looking at some word problems or some verbal descriptions and how we can find the slope from these types of problems. Now when it comes to identifying dependent variables, what you can look for in the problem is anything that is either related to money or whatever is not related to time. So again, anything related to money or anything that is not time in a problem. For the independent variable, it's just going to be the opposite of the dependent variable. So it would be anything that is time related in the problem, or anything that is not related to money. So let's go ahead and take a look at a few examples. I do expect you to write down the entire word problem, and I'll be looking for that when I check in your notes. For our first example, we have this. A hot air balloon was 75 feet off the ground 5 minutes after takeoff. The same balloon was 300 feet off the ground 20 minutes after takeoff. What is the hot air balloon's average rate of change? So essentially we're trying to find the speed at which the hot air balloon is climbing. So what I would encourage you guys to do first is to identify the dependent variable and the independent variable. Now there's nothing related to money in this problem, but there is something related to time. So that's what we want to identify here. So the dependent variable, which I'm going to abbreviate dv, and the independent variable, I'll abbreviate iv. The independent variable, we know anything related to time is going to be the independent variable. So we have 5 minutes and we have 20 minutes. Okay? And so we're looking for the change in the amount of time that passes. So if you think to yourself, all right, how much time passes if I go from 5 minutes up to 20 minutes? Well, if you think about that, from 5 minutes to 20 minutes, that's going to be 15 minutes. And the way that we get that is by taking 20 minus 5. Okay? The dependent variable, on the other hand, is going to have to do with the other variable, which in this case is going to have to be feet. So we have 75 feet here. We have 300 feet here. Okay, so we're looking for the change in altitude, or we're looking for the change in height. To get that, we're going to take 300 minus 75. So now our formula, again, that we used, that I gave you on the previous page, is going to be m is equal to delta dv over delta iv. And so we have m is equal to find delta dv, again we're taking 300 minus 75. And for delta iv, we're taking 20 minus 5. Now if we look at this here, this should look very, very familiar. It should look exactly the same as our formula for finding the slope from two ordered pairs. Okay, we have m is equal to, we have a fraction bar, we have our two minus signs. That should look very much the same as our formula for y2 minus y1 over x2 minus x1. Okay, so now what we want to do is we want to go ahead and simplify this. So we have m is equal to 300 minus 75. That's going to give us 225. And 20 minus 5, that's going to give us 15. And honestly, I just made up this problem, so I'm not sure if that's going to calculate well. But we want to figure out what that's going to be. So m is going to be equal to 225 divided by 15. That's actually going to equal 15. And we need to include our label. Our dependent variable measures feet, and our dependent variable is in the numerator, so we have feet. And our independent variable measures minutes, so we have feet per minute. So that means that every minute that passes, the hot air balloon climbs another 15 feet. And that's our answer for that first example. Let's take a look at a couple more. Second example says, a certain teacher weighed 200 pounds in 1998. That same teacher weighed 260 pounds in 2018. What is the teacher's rate of change? So again, we see a problem related to time. Okay, we don't have any money in this problem yet, but we see some time. So our independent variable, we have 1998 and 2018. Those are our measures of time. So to find our independent variable, we're going to take 2018 minus 1998. And then for our dependent variable, again, whatever is not time in this problem, so this is going to be weight. So we have 200 pounds and 260 pounds. So to find the change in the dependent variable, we're going to take 260 minus 200. All right. Now to find our rate of change, m is equal to delta dv over delta iv. So if m is equal to, our change in the dependent variable will be 260 minus 200. And the change in the independent variable will be 2018 minus 1998. So when we do our math here, we have m is equal to 260 minus 200. That's going to give us 60. And for our denominator, we have 2018 minus 1998, which gives us 20. We need to simplify our fraction, and we get m is equal to 3. And we want to label it. Our dependent variable is going to be pounds. So 3 pounds. We can abbreviate pound as LBS. I hope that we know that. 3 pounds per year. So that means that teacher gained on average 3 pounds per year. All right, for our third and last example, it says a student opened up a bank account in February with an initial deposit of $50. In October, the account had a balance of $370. On average, how much money did the student add each month? Okay, so we're looking for our dependent variable and the independent variable still. So we have our change in the dependent variable and our change in the independent variable. So here we have our first problem where we actually have some money in it. We also have time, but we do see that we have money. So we have $50 and we have $370. So our dependent variable, we're going to take 370 minus 50. And now for our independent variable, we don't really have any numbers for this, at least not at first glance. But what we do have is we have months of the year. We have February and we have October. Now if you think about it, October is the 10th month of the year and February is the second month of the year. So to find our independent variable, we can actually take 10 minus 2. Okay, and that will tell us how many months have passed since the student opened up the bank account. So we go ahead, m is equal to delta dV over delta IV. So M is going to be equal to 370 minus 50 in the numerator, and then 10 minus 2 in the denominator. When we do our math, we see that M is going to be equal to 370 minus 50 is going to give us 320. And 10 minus 2 is going to give us 8. So essentially, in 8 months' time, the student added $320, but we need to figure out how much he added on average per month. So if we do our division, we see that M is equal to 320 divided by 8. Hopefully we can do that in our head to get 40. So our rate of change is going to be $40 per month. Okay? Write down any questions that you have about this lesson. We'll be sure to go through this together as a class later on tomorrow.